Hello, hello. Thank you for joining me again for part three of the Ethical Skeptic's amazing, thought provoking article, Hidden in Plain Sight. We're going to pick up where we left off with natural tapestry belies an insistent narrative. Okay, folks, if you've hung with me so far, maybe it's been a little dry so far, unless you're really into the subject matter, which I am, so I didn't think it was dry, but we're going to get into the really new kind of earth-shattering stuff. So far, it's just all been about casting doubt on the official narrative we've been given so far about the age of the pyramids and method of construction of the pyramids. Now, we're going to talk about some of the more troubling evidence that affects us now and in the future. I'll resume. As mentioned at the outset of this article, I don't have a plausibility or ontological issue with the pharaonic Old Kingdom origin for Khufu and Khafre. I maintain an epistemological one. What he's saying here is he doesn't think that Khufu and Khafre didn't exist or anything like that. He has a problem with what we know or what we think we know about Khufu and Khafre. We've shown above that a classic Egyptian context for development of the Giza complex is certainly appropriate from a technological and labor resource perspective. What I have a problem with is being lied to, being gaslighted, and intellectual stagnation being passed off as the scientific method. I have a problem as well when directly falsifying and irrefutable evidence is ignored by those same actors who are doing the lying. Fortunately, nature has preserved for us a rather informative spectacle in the demarcation of Tura and Mokkatam limestone on the Khafre pyramid at Giza, the highest elevation of the three primary pyramids at Giza. Mokkatam limestone is quarried from the Mokkatam Formation, located directly underneath the Giza Plateau, 500 meters south of the pyramid's southern edge. This limestone is a dense and durable form consisting of older strata concretions of calcite, quartz, dolomite, and halite. Its composition makes Mokkatam limestone highly resistant to the action and chemistry of ocean water. Mohs hardness of 6 or 7, slake durability index of 95%, a process known as karstification, referred to here as karst erosion for clarity. Due to its low friability and high compressive strength, the builders of the Khafre pyramid employed Mokkatam limestone for the structural blocks that compose the main load-bearing courses, layers, and backing stones of the pyramid. In contrast, Tura limestone is a relatively soft form of limestone, Mars hardness of 3 or 4, slake durability index of less than 85%, and higher friability. It has a much more leachable microstructure and consists entirely of vulnerable calcite. It's calcium carbonate 3, something like that. This renders this form of limestone vulnerable to dissolution in seawater by means of the following chemical equation. And he gives a chemical equation here where limestone plus carbon dioxide and water and blah, 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 blah. Basically, it dissolves the part of the stone inside the microstructure here. Keep the detritus, loose, incomplete, and undissolved calcium carbonate heavier solids, byproducts of this chemical equation in mind as you continue to read. This carbonic acid process plays a significant role in the natural weathering of limestone and other carbonate rocks. It is also crucial in the formation of karst landscapes, where the differential dissolution of various hardness limestones by acidic saltwater leads to the creation of caves, sinkholes, salt spalling, Tefoni pitting, alveolar weathering, and other karstification features, especially along coastlines. The builders of the Khufu and Khafre pyramids chose the softer limestone for the decorative casing because of its beauty and ease of workability into a smooth outer casing surface. But this had also rendered the casing vulnerable to karst weathering and erosion. See footnote regarding the distinction. By ocean water, an event which the builders understandably had not felt the need to anticipate. The breakthrough at Giza. Several years ago, while working with my Egyptian client, I had the extraordinary opportunity to tour and climb off-limits areas, legally, inside and on the larger Giza pyramids. These fascinating tours left me trembling in awe each time I duck-walked through the primary passage into Khufu and onto the Grand Gallery. The air was uncomfortable and dank, but the monumental legacy of the surroundings made me oblivious to any discomfort. That's cool. I've always wanted to do that. I've never been to Egypt. It's on my list. During these observational visits, I could detect the pyramid construction foreman's use of fieldstone stacked slate placement technique, a technique used in particular by New England farmers to build pasture fences in the 1800s or decorate homes today, except this was done in the horizontal plane and not the vertical. The foreman only need ensure discipline in the vertical plane surface, a highly level and flat surface in the engineering vernacular. However, in contrast, the foreman exploited the convenient chaos of the arriving stone stream to provide him the shape resources he needed to fill in the horizontal plane puzzle, just like one would construct a slate stone or stack stone fence. As a qualified officer of the deck, navigator, and lifelong sailor, I have grown used to observing the effects of ocean water erosion, including karst and seawall erosion, on a variety of structures around ports and along coastlines. As we toured the Giza complex, I inquired of my driver/guide the reason for the removal of the Tura casing stones from both the Khufu and Khafre pyramids. He responded, quote, "Mr. G, they say that the stones were reused in ancient buildings down the local community, but in truth, no one knows what happened to them. As you can see, if indeed the Tura limestone casing stones were scavenged, I find it odd that none remain laying along the bottom of the pyramids themselves. Also, why did they stop at the cap?" I'm going to scroll up here and revisit this image. I think he's going to talk about it later, but you can see here, this is a big, big piece of this overall argument, which is going to become more defined as the article progresses. Undercut erosion from a waterline base here. So what I'm showing, if you're just listening to this, is a picture of the Khafre pyramid, and what you'll see if you look up the pyramid is the casing stones towards the top at the tip are still there. They're a little weathered, but they're there. And then starting from a certain point, and all the way down at the base, they're completely gone. But it's not like a flat straight line on each edge under which they're gone. It curves upwards at the corners. And the Ethical Skeptic is going to talk more about this in a bit. But he's starting to say here that this is evidence of what he calls wave action-induced seawall erosion, which he's about to talk more about now. Continuing, and here's a rare photo of the Ethical Skeptic. Can barely make out his face here. Boop, boop, boop. All right. In fact, there are some remaining casing stones which were not carted off and lay scattered about, ignored by history and scavenger alike at the base of Khafre. They're all made of granite, Mohs 7-8, or were covered by sand and therefore only partially karst/travertine eroded and reconcreted. Such is a Sherlock Holmes-worthy deductive clue, as only the seawater solvable blocks had disappeared from both the pyramid itself as well as the entire Giza complex. Instead, both pyramids are covered in a heavy limestone detritus, which could not have been deposited by winds. Am I doing this right? Detritus, I think, isn't it? Pronunciation.
Detritus.
Detritus. Ugh, God, forgive me. Pronunciation in English. Okay. Continuing, moreover, under the narrative, the Mohs 6 backing stones on Khafre and Khufu have weathered far more in 800 years than have the softer Mohs 4 travertine limestone blocks off the Roman Colosseum in 2,000 years. A ludicrous comparison which falsifies the official archaeological narrative can be seen by clicking this image. Ah, shit, that is actually a very good point. So, like, the harder stone in a drier climate that receives, in theory, much less rain than, say, Rome, has weathered to an insane degree. Meanwhile, the Roman Colosseum, with an even softer limestone over twice as long of a period, has weathered like almost none. Ugh, God, sometimes it's like you just look at these things and it's like, it's so obvious. It's so obvious. And like, what are they going to say? Like, what is an archaeologist going to say when they look at this photo? Yeah, like, I would explain it to you, but you just wouldn't get it, okay? Like, leave it to the professionals. It was there at that moment that it finally hit me. The Tura limestone casing blocks hadn't been scavenged at all. If they had been taken for reuse, why were only the granite-based stones left scattered about? Nor could their complete obliteration have been the result of an earthquake, which somehow managed to selectively erase Tura while leaving Mokkatam untouched. The patterning and undercut nature of the casing stone depletion at the top of the Khafre pyramid renders those explanations ridiculous fairy tales. And he's pointing back to the images that we just looked at and described. No, the Tura limestone blocks had not been scavenged. They had been dissolved, broken down by the ferocious kinetics and carbonic acid chemistry of ocean water. Exhibit E1, this was another one that's really stuck with me. So this is a picture of the Khafre pyramid, and you can see if you look at the pyramid that not only is there this cap of casing stones with the curved parabolic weathering pattern at the bottom of it, but there's also this band just beneath it that goes, I don't know, maybe 10% or so of the overall height of the pyramid. And it's even more weathered in this one band. And then below that is just a bunch of other erosion, but it's almost like a different type of erosion. Like there's something different that happened at this boundary layer relative to the rest of the pyramid below. Now, it wouldn't be rainwater. The rain is not going to hit this random section all around all four sides of the pyramid in some sort of concentrated way. It has to be something else. It's not going to be wind. It's not going to be sand. It's not going to be people who just hike up to this one random portion of the pyramid and just, chisel away randomly for something? No. It's got to be something else, and that something else is what the ethical skeptic is saying is wave action. So we'll talk. There's more evidence to this claim besides just what I'm describing, because some of you who are listening to this, who are hearing this for the first time, I'm sure your defenses are up, as mine were. We'll continue. Plainly visible karst erosion band is created by pause in the sea level of a dramatic oceanic displacement, not flood, from antiquity. Its sustained height and recession marks have been left for us to ponder and draw inference, both in the form of horizon-disciplined and wave-chaotic signatures placed at just the correct height separation which natural ocean sea state variance would serve to impart. Just as in the case of the Leo Stela at Nimrud Dag while working in Turkey, Pillar 43 Göbekli Tepe, and King Solomon's lost mine of Ophir while working in Africa, the realization dawned on me inescapably like a summer sunrise cutting through the morning fog. One may encounter the eyes of the enigma for years and suddenly in a single glance comprehend it utterly and completely, a penetrating affair that renders 1,000 prior gazes entirely moot. See the detritus at the bottom. We're going to talk more about the detritus here in a bit, which I'm going to keep saying because I have, started pronouncing it correctly. Detritus, loose, incomplete, and undissolved calcium carbonates heavier than ocean water solids. I think that's calcium carbonate. Showing partial reconcretion, resting on the most seven backing stones and accumulating in a parabolic mound that tapers up with triangular pyramidal face height, as this hypothesis predicts, at the base of the Khafre pyramid. This was all cleaned up without the first question being posed by archaeology. I was silent in the car on the way back to the hotel, my stomach hanging like lead under the weight of what I had just seen. My colleagues even inquired if I was well. I was not. The metrics and evidence. I have observed that Egypt runs out into the sea further than the adjoining land, and that shells are found upon the mountains of it, and an efflorescence of salt forms upon the surface, so that even the pyramids are being eaten away by it. Herodotus, an ancient account of Egypt, 440 BCE. Accordingly, I have outlined the measures and dynamics of this particular form of karst erosion in exhibits F, G, and H below. The gray areas in exhibits F and H represents an ocean level which is 576 feet higher than our current day normal. This represents the height of ocean above current sea levels, which is required to create this fast-paced karst erosion visible on both the Khufu and especially the Khafre pyramids. A 576-foot pause in the sea level is the origin of that light-colored karst erosion band shown in the exhibits E1 and E2 photos in the immediate above, as well as in exhibits F and G below. This erosion band was caused by a highly energized ocean averaging a sea state of 6 to 8 over a significant period of time. I have sailed a ship in sea states 7 and 9 before. These were terrifying events, with waves taller than my bridge wing and ship. Therefore, the waters appear to have retracted almost as quickly as they encroached. This is a warning flag that we should heed and understand as mankind. Take your time in examining Exhibit F below, as it's packed with relevant deductive observation. So there's a diagram here. Tura limestone inundation, erosion. Oopsies. Okay. Vulnerability to seawater contrasted by Mokkatam limestone durability, structure and nominal Tura weathering, casing. The erosion band measures match the erosion characteristics of an average sea state of 6 to 8 at a high water pause. The height of water at this pause equates to a 264 foot Khafre base altitude plus 312 foot inundation mark height on the Khafre pyramid, a 576 foot global or regional inundation. He's about to talk about this a little bit more, but basically it surprises a lot of people to hear a couple of facts about the pyramids. First off, it's not entirely level. The one pyramid, like the plateau itself, kind of tilts just a little bit, and then also the sea level. It's not at sea level; it's a good bit above sea level. And for the Khafre pyramid, it is about 206. The base of it is about 264 feet above sea level, and the part where this wave action is happening here is about 312 feet high. And what he's saying is that, you know, if you take the measurements of these parabolas, that you can work out how high the waves were that were lapping up the side of the pyramids. And from that, you can deduce using, I guess, what they have as a standard sea state kind of metric that we use. And he says this corresponds to a sea state of around 6 to 8, once the water has achieved this high level anyway. Below, one can observe the horizon discipline is in water level karst erosion, which is centered around the 312-foot level, 506 feet above sea level of the Khafre pyramid. There is only one factor which can cause such an erosion pattern. In a Holmesian sense, even though this factor may seem like an implausibility, the characteristics of these marks serve to eliminate every other possibility, and we are left with only one possible answer. This was caused by a global or regional inundation. There is no possibility that this happened through human intervention, stone scavenging, or pyramidal structure vulnerability. You see a diagram here from the top looking down at the pyramid, and you can see what another thing that's interesting is that the erosion patterns are symmetrically centered on the pyramid apex. Although as I'm looking at this, I have to say it does look like there may be a little bit more on the west side. I don't know. I don't know what the actual measurements are. That might not be significant, but it also to me might mean a west to east movement of water was a little bit more severe perhaps than the east to west. Exhibit G, the horizon discipline nature of the karst erosion serves to falsify every competing notion as to how the Tura limestone blocks have been removed. Yeah, and there's just a bunch more diagrams showing this. Goosebumps to put it lightly. Of course, the natural question arises, why did this same uneroded Tura limestone cap not occur on the Khufu pyramid as well? The first part of this answer lies in the relative altitudes of each pyramid's peak. The Khafre pyramid, despite being slightly less tall than the Khufu pyramid, nevertheless sits upon a higher Giza plateau section than does Khufu. This turned out to be just high enough to preserve 110 feet of Tura limestone casing, which extended above the level of this catastrophic ocean condition. One can easily observe the receding water lines descending from the erosion band, which left this cap in place on Khafre. I'm going to click this image. Receding water lines. Ah, yeah. Yeah, receding water lines. So there's like, every now and then there's like another horizontal band as the water recedes, which is a pretty common. If you spend much time in the woods around water, around coastlines, you'll recognize that. These erosion bands exist on both Khufu as well as Khafre. Here, the oceanic inundation receded as the land rose by means of mantle viscoplasticity. In answer to this question, however, the Tura cap or pyramidion of Khufu did exist. First, there is a minimal Tura structure viable, which can support its own weight long term, earthquakes, weathering of mortar, etc. Plus, the cap of Khufu was renowned to conceal a quantity of gold, or at least gold plating. The entire cap was removed and purportedly reassembled on the ground level of the southeast side of Khufu. I have seen this pyramidion up close, but I have no idea whether or not it's the original. So there's no doubt that, unlike the case of Khafre, the Khufu Tura cap was manually removed. And so you can see here, there's another diagram of the Giza plateau topology. Khufu's base is about 218 feet lower relative to sea level than the Khafre base, so the altitude is higher for Khafre. Even though Khafre is a shorter pyramid, it's actually a good bit taller than Khufu relative to the sea level. These stones belie archaeological buffoonery. You know your theory is strong when it consistently predicts exactly where the counter-narrative will need to insert a lie to support its argument. That's a powerful quote. The individual traditionally credited with removing the casing stones from the Great Pyramid of Giza is Al-Aziz Uthman, the Ayyubid ruler of Egypt and son of Saladin. He is said to have ordered the removal of these outer casing stones in the late 12th century, around 1196 CE. However, as we will explore below, a review of the original source documents reveals this narrative to be incorrect. I was able, after significant effort, to find and translate the entire relevant Chapter 4 of Islamic historian Abd al-Latif al-Baghdadi's writings circa 1196 CE. In this travelogue-styled recount, al-Baghdadi cited that al-Aziz merely destroyed, quote, a considerable quantity of pyramids, small in truth, quote, and used, quote, the stones that came from the demolition of the small pyramids that he had destroyed in the construction of the arches that we see present at Giza. End quote. Notably, there's no mention anywhere of his account of the removal of the Great Pyramid's casing stone. This falsification is deductively significant as Abd al-Latif was investigating the Giza pyramids just prior to the time this event is alleged to have occurred. In fact, the same authoritative word often cited regarding the Giza pyramids, quote, retaining their casing stones as of the 12th century, quote, Relation de l'Égypte, the French translation by Abd al-Latif al-Baghdadi, provides a description of Khufu in the following terms. Quote, but let us return to the two great pyramids of Giza. The Khufu pyramidal figure is truncated at the top, providing a flat plane of 10 cubits, 17.2 feet, on all sides. Notice that the pyramidion is already missing. We were told that in a neighboring village there were people who regularly climbed to the top of the pyramids and could do so with ease. So we sent for one of these men, and for a trifle that we offered, he did indeed climb one of the pyramids as one would climb a staircase, and very fast, without taking off either his shoes or his clothes, which were very loose. Al-Baghdadi cites that the climber scaled to the truncated top and measured the flat area with his turban. Islamic historian Abd al-Latif al-Baghdadi makes four key narrative fatal observations in Chapter 4 of his work. 1. The Khufu pyramidion was already missing by 1196 CE. 2. Al-Baghdadi clarified that Al-Aziz Uthman disassembled only a series of small pyramids to restore the Giza temple, an effort framed to downplay for posterity the Ayyubids' ruler overall its impact on the ancient monuments. 3. The casing stones of the Khufu pyramid were absent both during and before al-Baghdadi's time at Giza. Al-Baghdadi described a hired climber scaling the pyramid, quote, as one would climb a staircase and very fast, which would have been impossible if the pyramid were still covered with 52 degrees angled smooth precision-fitted casing stones, even in a condition similar to the partially preserved casing on the Khafre pyramid today. 4. The casing stones had been absent long enough for, quote, more than 10,000 pages, quote, of inscriptions, most of which were neither hieroglyphic, hieratic, nor any other recognizable script of the time, to be carved upon them, suggesting that they had been missing for millennia before al-Baghdadi's visit. This 12th century testimony, along with the 10th century one below from Islamic historian al-Mazudi, allow us to confidently infer that the following narrative claims are false in terms of being the principal reason for the casing stone complete absence. While it is plausible that some stones, whether backing or casing, were repurposed for later construction, attributing this as the sole cause of their absence is highly speculative at best. 14th century Egyptian historian Taqi al-Din al-Makrizi's claim that the pyramids were used as a convenient source of high-quality limestone for buildings in Cairo, and that Sultan al-Aziz Uthman, son of Saladin in the 12th century, attempted to dismantle the Great Pyramid's casing stone but, quote, found it too difficult. 14th century Moroccan explorer Ibn Battuta's claim that the partially stripped state was anything other than what we observe today on the Khafre pyramid. 14th century Islamic historian al-Makrizi's claim that Sultan al-Nasir ad-Din al-Hassan used the casing stones to build parts of Cairo, and in particular the Mosque of Sultan Hassan. In 1440 BCE, Greek historian Herodotus observed the pyramid stone had already been eaten away by salt, thus they would not have been a sound resource for later building projects. The persistence of the obfuscating myth around the casing stones is a result of both laziness and the dogmatic disposition within the discipline of archaeology. Scholars often fail to thoroughly examine their own source material. In some instances, archaeologists have even been known to misrepresent facts, falsely asserting that al-Baghdadi documented the presence of casing stones when he actually noted their absence. A clear example of this deliberate misrepresentation can be seen in this Khufu pyramid video produced by History for Granite. I'm not going to click it. I believe I'm on this one. Regarding the courses of Khufu, as Abd al-Latif al-Baghdadi described them, features that would have been obscured if the casing stones were intact. He personally examined the stair-stepped backing stones and provided the following observations regarding the mysterious script he observed. Quote, the stones are covered with writing in ancient characters, the interpretation of which is unknown. I have not met in all Egypt anyone who could say that he knew, even by hearsay, anyone who was familiar with these characters. These inscriptions are so numerous that, if one were to copy on paper only those that are seen on the surface of these two pyramids, one would fill more than 10,000 pages. Indeed, as referenced in the notes accompanying this section of Antoine Isaac Silvestre's De Cécie's translation of al-Baghdadi's Relation de l'Egypte, the 10th century Islamic historian al-Mazudi is recorded to have written, quote, in Egypt are very tall monuments of a marvelous construction. Their surface is heavily adorned with inscriptions written in the characters of ancient nations and kingdoms which no longer exist. We do not know what this writing is, nor what it signifies. Clearly, these characters were neither Egyptian hieroglyphs nor hieratic script, both of which served as the official writing systems of Old Kingdom Egypt as early as 3100 BCE. By the time of al-Mazudi and Abd al-Latif al-Baghdadi, hieroglyphs and hieratic script were well recognized, though not yet translated. It is equally apparent that this ancient script, whatever it may have been, has since been erased from the stones of Khufu and Khafre, leaving it lost to history. The astute researcher will recognize this as a consistent pattern in any investigation into the history of humankind on this planet. Quote, by the 12th century, during the time of Abd al-Latif al-Baghdadi, the Tura limestone casing stones of Khufu's pyramid were already completely gone. The exposed backing stones bore inscriptions and characters that predated 3100 BCE, providing compelling evidence that the casing stones had been absent from the pyramid for a significant period, well before the 4th dynasty of King Khufu and even prior to the establishment of the Old Kingdom itself. Deductive reconcretions and more archaeological buffoonery. Detritus, loose, incomplete, and undissolved calcium carbonates heavier than ocean water solids. Accordingly, we are left with a sustained and specific sea level oceanic displacement as the only viable explanation for the unique features we document in this article. Not a 371-day biblical flood, not a tidal wave, not a cosmic impact, and not an interloping gravitational visitor to our solar system, but rather a long-term and Earth rotational mechanics-derived oceanic displacement. Something befitting a disruption or magnetic decoupling of our planet's rotational component masses commensurate with a weakening of Earth's geomagnetic moment, inner-outer core magnetic coupling with the outer rotational mantle asthenosphere lithosphere, an event which is happening once again from 1973 until now. See chart here. This is a chart of the movement of the North Pole, the magnetic North Pole of Earth. South Pole stays about the same, but the North Pole is moving a lot. In fact, desert sand-based shaped calcium carbonate reconcretions at the foot of the pyramids, click on image above to see these heavier than ocean water solids reconcretions, confirm that the Tura limestone was dissolved, not removed. The incomplete and undissolved portions of the calcite plummeted to the foot of the pyramid and reconcreted over time. One can observe the resulting karst/travertine erosion in these two photos of Khafre's Tura limestone footer casing stones. So he's saying that you can see these are like this kind of rock here that I'm showing you at the base of the pyramids is basically like the stone deteriorated. It was sort of melted by the seawater, right? Dissolved. And then it reconcreted. So what it would have done is it would have washed this kind of slurry mixture out of the casing stones. And then it would have kind of piled up here at the bottom and then reconcreted into a mass. This is unmistakable evidence of oceanic inundation. Had this observation been managed by scientific professionals, the material in the photo to the above right would not have been ignored so carelessly. Such buffoonery exemplifies why ignorance and paradox continues to surround these two pyramids. These surviving footer casing blocks were protected by encroaching desert sands, and the reconcretion was bottom-shaped by those same protective sands. The juxtaposed alignment of the two constitutes deductive evidence and is no coincidence. Moreover, a video posted 6 months after this article was released by Uncharted X adeptly highlights the extensive erosion of the limestone blocks at the base of the Khafre pyramid. However, they overlooked the karst carbonic acid factor we cite as part of this hypothesis and instead referenced a classic friction-only scenario, suggesting it would take 12,000 years to erode a structure by 2 feet through normal waterborne action. According to our hypothesis, this is not how the softer limestone blocks pockets eroded at all. The pitting and scooping seen in the video are indicative of Mohs 3/4 chemical erosion, not mere physical friction from rain, wind, sand, air, or water. What they're inspecting in the video is the Mohs 5+ harder limestone, which survived the karst chemical action, thereby giving them a false reference upon which to base a timescale. The inside of the south air shaft running from the Queen's Chamber also exhibits the same karst travertine erosion. Yeah, so this actually is a part also that made me really sit up and listen. Is not just the outside, but the inside and what's found in there. In this linked photo from the Jetty project as well, one can observe both the travertine erosion of the Tura limestone walls. It appears as if the limestone wall is melted, coupled with efflorescence crystalline incrustations growing off of the travertine surface of the stone from ocean water leaching. So this is inside the Queen's Chamber, and you can see Tura limestone travertine decay, ocean water salt efflorescence. This passageway was filled with ocean water at some point in time. ChatGPT 4.0 comments on these photos linked above. The features you're observing, including the smooth weathered surface with rounded pocks and newer, sharper incrustations, are consistent with the history of travertine erosion followed by salt efflorescence. This supports the hypothesis that the shaft experienced a prolonged exposure to mineral-rich water, possibly from an oceanic source, followed by evaporation and salt deposition. Additionally, in his work, The Pyramids and Temples of Giza, which comprises the notes of British Egyptologist William Matthew Flinders Petrie. Petrie wrote the following observations during his excavations and examinations of the subterranean chamber of Khufu. Quote, soon after passing this granite, we got into the lower part of the entrance passage, which was clear nearly to the bottom. Here a quantity of mud had been washed in by rains from the decayed limestone of the outside of the pyramids, thus filling the last 30 feet of the slope. The limestone was easily smashed and then and there and carried out piecemeal, and as it had no worked surfaces, it was of no consequence. Indeed, in 1611, Francois Savary de Breves confirmed that the subterranean chamber passage was, quote, completely plugged up to the upper chamber access point, quote. Additionally, this 1950s photo, right, of Egyptologist Adam Rutherford working in the upper section of the subterranean passage, compared to that same passage as it is today, shows almost a foot of filled-in and over-ancient reconcreted limestone, soft and foot-worn, not bedrock, in that passageway. This had accumulated upon the unchanged bedrock base of the passage, which would bear minimal footwear, if any at all. Obviously, this concretion has been filled in / covered and is likely still there if archaeology had the ethical gumption to take a sample of it. So you can see this is what the passage looked like in the 50s. There's a photo before this had been this reconcreted limestone had and so it's just this soft reconcreted limestone that had been dissolved and sort of washed in. And then on the right you can see they have they filled it in is what they did. So as opposed to sort of recognizing that this was washed in, they filled in the whole middle period now. So the original base was a good bit lower. It was down here, more than 47 inches. It shows that there's 47 inches tall from the top of this piling up of reconcreted limestone. Now that it's the same height if you were to go visit that passageway now, because they filled in the middle. It sort of assumed that all this reconcreted limestone was the original floor, but it was not. The original floor is probably a good foot or more below. Wow. Thus you are mistaken, Sir William Flinders Petrie. This limestone was indeed of consequence. Your prior assumption that this edifice was a tomb built in 2500 BCE, lack of scientific discipline, and shortfall in broad experience in materials, geology, and oceanography harmed this archaeological process. From these notes, it is clear that the limestone which blocked the subterranean flat passage, one, was from the decayed limestone on the outside of the pyramid. Notice there was no sand, which would have blown onto the outer stones and washed in with the rain and dissolved limestone into and down the passage, so this could not possibly be from rain. 2, it was transported there by inundation carriage alone, as rains could not possibly build 30 feet of structure only at the bottom, because running water over thousands of years would have produced a long limestone and sand encrusted rill, an intermittent flow creek bed formation down the entire length of the passage. Instead, 3, it had aggregated into this massive concretion structure long after the pyramid's construction, and 4, such structure was often carelessly removed by those who did not comprehend that this concretion was predictive evidence and should not have been destroyed without professional archaeological documenting. Petrie continues by describing the horizontal passage cut into the limestone bedrock running south from the subterranean chamber as follows. Here again, Petrie did not follow scientific protocol, operating from a flawed prior assumption. So here is a diagram showing this 30 feet of dissolved Tura limestone reconcretion in this chamber, subterranean chamber. There was also 3 inches of marine silt deposition along the shaft. The evidence just keeps piling up. I'm going to move forward. Moreover, salt incrustations found within the Queen's Chamber of the Khufu Pyramids, as well as the Grand Gallery, might serve to confirm the overarching seawater inundation construct. However, here once more, we do not hold a sample of this salt. We must recognize that some salts, chemical compound class, not sodium chloride per se, can be derived from limestone given specific conditions. efflorescence of potassium nitrate or two other chemical salts through exposure to ocean water as well, calcium carbonate and calcium sulfate. Ocean salt would only remain in certain ideal conditions in places, which is indeed the observed case. Efflorescence, in contrast, should be ubiquitous, yet this is not the observed case. Evidently, the lack of such efflorescence homogeneously distributed throughout the pyramid weakens this argument approach, however, making it appear desperate and ad hoc. Furthermore, from a logical standpoint, a purported shortfall, which is actually false, see the Upnout project photo to the right, in detecting these three ocean water-derived salts does not critically undermine our hypothesis presented here. Quote, but beyond this and onto the Queen's Chamber, the very thick and hard incrustation of salt which entirely covers the wall of this passage made it impossible for us to locate the joints with any certainty. This salt incrustation is peculiar to the horizontal passage in Queen's Chamber, although a little of it may also be seen on the walls of the first ascending passage. This is John and Morton Edgar, Great Pyramid Passages, Volume 1, 1910. So some of these passages have very thick salt incrustation, making it difficult for people to even see where the stones begin and ended. Nonetheless, inaccessible salt incrustations, which cannot be feasibly from efflorescence by the deductive logic we just cited above, and therefore had to be derived from direct ocean water exposure, have recently been found on the Queen's Chamber North airshaft ceiling blocks. Again here, the lack of chemical sampling of this salt is a deficiency of the discipline of the archaeological prevailing narrative. This was critical path evidence neglected through professional buffoonery. Notice here a key differentiating warning flag within philosophy. The prevailing burial chamber narrative becomes stronger only as less and less information is found or retained. It's a good point. As evidence keeps getting lost, ignored, destroyed, then the narrative becomes stronger and stronger. Such evidence suggests an entirely new possible rationale behind the existence of mysterious pictographs, or the myriad ancient stone circles which track the seasonality rising and setting of the sun and moon. Perhaps these were neither fanciful art nor seasonal calendars as much as they might have been a warning indicator that it was high time to get to higher ground. Archaeology, perhaps inadvertently and in an effort to avoid any evidence that might even hint at supporting a biblical flood, has created an echo chamber of sorts inside their own profession, leading to an overall ignorance vacuum regarding this topic. Impossible? Think again. The reality is that this natural tapestry doesn't merely express itself upon the Khafre and Khufu pyramids alone. In fact, it shows throughout the entire landscape of the Arabian desert and into northern Africa. I spent a couple years off and on traveling the Arabian Peninsula and the Saudi Empty Quarter, surveying the region during a national strategy I conducted for the Kingdom of Saudi Arabia. There, I observed the ancient receding shoreline structures in the Empty Quarter for months before it finally hit me as to what these indeed were. They are recent, less than 12,000 years ago, ocean shorelines. If you were as indoctrinated as I was and believed for decades that since we did not know about it, that such a flood was impossible, this will serve to limit your perceptive abilities. Once you see this, however, you will not be able to forget it thereafter. Exhibit 1 shows the extent of a 576-foot inundation. This is a diagram showing like a elevation map, and it shows that a 576-foot inundation elegantly fills the entire green area, 590 feet and lower on this topographical map, to include the Saudi Empty Quarter as well as the entirety of the Nile Delta and Giza Plateau. Basically, there's this Saudi Empty Quarter. What is the Saudi? It's a desert. It's a big desert. So basically, if the ocean rose to this amount, it would perfectly fill what is now a desert. Now compare Exhibit 1 to the Google Earth satellite composites of the region, displaying washways, saline flats desert, and iron oxide orange depositions at high water marks. You know, I've always thought this. Even Jimmy at Bright Insight talks about this. He sort of shows these big sweeping motions in the desert, in the Saharan desert, and he says that he thinks it's from, you know, a big sort of flood that wiped out Atlantis on the west coast, which may be true, I don't know. But I've always seen these, and not just here too, but even in North America, you see a lot of this. And what the Ethical Skeptic is saying is that these were receding shorelines. Receding shorelines. Hmm. While we present two pieces of compelling evidence in the form of Khafre erosion and geological features of the Saudi Peninsula, each acting as a form of white crow, dead body evidence that falsifies previous conventional theories, this is not the only evidence of a partial Earth inundation. It's important to note that while our goal is not to promote Noah's flood or creationist theory, such evidence of a partial inundation does exist. Exhibit K2 shows the clear consistency in the 2355-foot high flow watermarks of the same inundation, along with the resulting diatomaceous seabed waterflat, a signature feature of such inundation zones, not from wind or weathering. The same striations in diatomaceous basins resulting from the catastrophic oceanic inertial flow shown below can also be observed in this video of the West African Reshape structure, courtesy of Archaic Lens on X. This is the structure that Jimmy at Bright Insight says is Atlantis. These striations and, critically, these salt diatom deposits never buried by supposed blown sand are not product of wind, but instead extend across nearly the entire Sahara Desert in a uniform north to south kinetic pattern. So this is a big part of the land around modern day Chad, and there's striations happening across, which, I'm not going to get into all of the details, but is more evidence for an oceanic displacement theory, according to Ethical Skeptic. Okay, I think I'm going to pause this here for now. We're going to resume in the next video, but hope you're not reeling too hard from some of these revelations. There are many more to come. We are about halfway, almost halfway through this article. Maybe a little bit more, actually. There's a lot of images further on, but you're going to want to stay tuned and check out the rest of this. And if you haven't seen it, of course, you can read the full article. It's linked in the description. Thanks for watching. Let me know how this is going, and I will see you next time.